Number 9. Which of the following graphs best illustrates the relationship between force and distance? And again, we're referring to this formula over here. And we've looked at some examples of plugging in different values for distance. And we know that as distance gets bigger, as the distance grows, the force gets smaller. So let me just copy this conclusion that we drew, because that will help us to answer this question. So they have given us 5 graphs to consider, and distance is plotted on the x-axis. Force is plotted on the y-axis. And this is because distance is the thing we can control. It is the independent variable. And so it's sitting on the x-axis. And if you look at just the general shape of this graph, let me just draw a general shape. Let's make sure that we understand what's happening here. So on the independent axis, which is the x-axis, this is the thing that we as the experimenters can control. If I set this up as an experiment, I decide how much distance is in my problem. So this is the independent variable where we're measuring the distance covered. So here is 0, 0, origin, which means no distance is covered at all, and no force would be affected because nothing has happened, essentially. But as this axis runs to the right, to the positive direction, we're gaining distance. So this is saying that distance is increasing. Now, if you go back to our conclusion, what would we expect to happen as distance gets bigger? The force would get smaller. So this dependent axis that's measuring force would show less and less force associated with the greater distance. And I know that's very complicated. I may be making this worse. I probably should just do the problem. But here's the reasoning. As the distance gets bigger on the x-axis, the force is going to what? Get smaller. And that is a negative slope. So we're looking for something that is negatively sloped. So let's look at our options here. Number 9A is showing me that as distance grows, what happens to the force? It's also growing. It's getting taller as the distance grows. So force is getting bigger. We want it to get smaller. Force is getting bigger. Distance is getting bigger. This is not what we're looking for. Okay. In this scenario, here's no movement at all, no force at all. So as distance is growing, that means it's moving this way. What is happening to force? It's also growing. And again, that is not what we want. That is a proportional relationship where both are growing in unison. Okay, in this one, as we move this way, as distance grows, what is happening to force? What's happening on this axis? It is also growing. And this perfectly straight linear graph tells me that it's growing at a constant rate. So not only is it growing, it's growing the same amount every time. But again, bigger and bigger is not what we want. We're looking for bigger on distance, smaller on force. So D, you can even see that the direction changes. And this is what I'm looking for. On the independent axis, distance is getting bigger. We can see it moving further and further this way. But what is happening to force? Force is biggest near origin. It's starting out up here and it's falling. Okay, so this is a possibility. Force is dropping as distance is getting bigger. And in fact, this is the answer that we're looking for. And let me plug this in. As distance gets bigger, that's this movement, force is coming down. Force is dropping. It's getting smaller. This is the answer we're looking for. So let's look at why this is not the answer. Okay. Why is it that E is not the answer? Because distance is getting bigger. We start out over here. The line moves out on the distance line. Force is also falling. Force is coming down as distance runs out to the right. So force is falling. The problem is that the shape of the graph is wrong, and I'm not going to go into this in great detail for risk of confusing you. Let me just say this. I would expect the force values to sort of hug. Sorry, my pen went a little wonky here. The y-axis in the beginning. And let me go back to our values to show you what I'm talking about. If you take a look at these fractions are getting smaller and smaller and smaller, but they're not drastically getting smaller. So for example, let's say that if distance is 3, then this would be 1/9. When distance becomes 4, this drops to 1/16. When distance becomes 5, we get 1/25. So those values are going to hover close to the y-axis in the beginning. They're going to sort of hug up against that y-axis. As they gradually get the denominator in that fraction changes, they will gradually move away from the y-axis until they're practically touching x, but they will never touch x. They will keep getting closer and closer to the x-axis, but they will not touch it. So the curve needs to be in this shape. And again, I'm not going to go any further than that because I don't want to confuse this situation. This is a tough problem, in my opinion. In this graph, I can show you, let me show you the colored version here. You see that is it's not hugging the y-axis at all. It's way over here. It's falling at a much faster rate than I would expect. This is one of those problems that if you don't know, just take a guess. That is okay to do. This is a tough one, and it's really hard to explain if you don't have, this is almost getting into some calculus, but it's tough to explain if you don't have that extensive background. If you can eliminate A, B, and C because force is getting bigger, then you at least could guess between D and E.